See, I told you it wouldn't be that long. Let's look at another example here. We want to classify this polynomial by its degree. Well, how do we find the degree of a polynomial? We're going to look at the degree of all the monomials that make it up. Our degree here is 3. Our degree here is 2. Degree is 1. Degree is 0. So that's our highest degree, so it's a third degree. And we would also call that cubic. And how many terms do we have? I didn't ask for the terms, but let's talk about it. 1, 2, 3, 4. So it's a cubic polynomial. We don't have a word for a 4-term polynomial, so we're just going to call it a polynomial. So that's a cubic polynomial. Our next one is not 1. We are going to talk about it, but we're going to talk about it in the context of a geometry application. And this is actually pretty cool. It's actually a physics scenario. So it talks about the height of a ball, some number of seconds after being thrown into the air, can be modeled by the polynomial of -16t squared plus v sub 0t plus h sub 0t. We're probably a little bit confused about these areas, these variables with the subscripts. That's really standing for v sub 0 is the initial velocity and h sub 0 is the initial height. So if we were on the ground, our initial height would be 0. If we were standing on a building, our initial height would be however tall the building is. If we were standing in a ditch, our h0 would be somewhere below 0. And initial velocity, that is something that is actually something we can figure out from calculus and stuff. So we're not going to worry about it too much. We're mostly looking at classifying that polynomial based on the variable t by its number of terms and degree. So let's write this out so we can mark it up a little bit. V sub 0t plus h sub 0. So let's see, we've got 3 terms, so it's a trinomial. We can definitely tell that. And the degrees. This is a second degree, that's a first degree, a 0 degree. So our highest degree is 2, so we have a second degree trinomial. We also call second degree expressions quadratic. So we have a quadratic trinomial. And that's actually the only one I think that doesn't really fit into the other ones. I mean, monomial or a constant, something linear. Quadratic, it doesn't quite make as much sense to me in the English realm, like the other ones and all those other prefixes. But I think we'll get over it because we're going to be working with quadratic so much. We will definitely get used to it. Okay. So now we're going to talk about how we add polynomials. And we've been doing it already. And it works actually exactly the same as adding any kind of multi-digit number. It's really kind of about place value. Now with our digits, we have the hundreds place, the tens place, the ones place, and things like that. And we line those all up. When we're doing polynomials, instead of looking at place value, we're looking at degree. And we're going to line up all the degrees. So there are actually 2 techniques for adding polynomials. The big idea here is, yes, we can add and subtract polynomials with like terms, but we have to remember what a like term is. So a like term is just kind of a review question. A like term are, we'll call them terms with the same variable to the same power. So constants, what we've been doing since kindergarten, adding numbers together. That is combining like terms. What we did with systems, we did a lot of combining like terms. So this is just kind of a refresher of what like terms are. So there are two techniques for adding and subtracting these polynomials. One way is vertically, which is kind of what I described. We're going to take these polynomials and we're going to line them up. We're going to stack them, but we're going to make sure that they are in degree order and that they are we are lining up our degrees. So we might do something like 2a squared plus a plus 1. Well, the second thing here doesn't have a squared term, so we're going to line this up right here. And we're adding. So then we go 1 minus 6 is negative 5. A plus 3a is 4a. And 2a squared plus nothing is 2a squared. We have just added polynomials. Now, this is not how we've been doing it all along, I don't think. We've been doing it more horizontally, which is okay if our polynomials are short. If they get long, it's kind of easy to get lost. But if we're doing this horizontally, it's actually already set up horizontally. Let's get rid of those parentheses because we don't really need them since the operations here are all the same. So let's see. We've got a 2a squared, but no other a squared terms. Okay, 2a squared. Done. Then we've got the a and the 3a. Well, that makes a 4a. And yeah, I actually crossed these out so I don't double count. And then we have 1 minus 6. This gives us our minus 5. If you need to group them before adding them, that's perfectly fine because you're just using the associative property. It just adds an extra step, but it also makes things easier to see. 2a squared plus a plus 3a plus 1 minus 6. That makes it a lot easier. Then we've got 2a squared and 4a and negative 5. So there's actually, like I'm going to say, 2.5 different ways of adding and subtracting polynomials. So this was not too bad. We had a trinomial plus a binomial. Not a big deal. Here we have a 4-term polynomial with a trinomial. And again, we really want to pay attention to the degrees of each of those terms. So if we write them vertically, and we usually like to write with the longest one on top. It's just something we're kind of used to, something that's been ingrained into our brain since, I don't know. So we have a 4th degree here. That we have a 3rd degree. Now we have a 2nd degree. Now we have a 1st degree. It's not in there though. So it has a coefficient of 0 plus our constant. Now we add our 4th degree. We do not have a 3rd degree. Now we have a 2nd degree. We don't have a 1st degree. And then our constant. And so now we've got it all lined up. 7 minus 3, that's 4. 0x plus 0x, that's 0x. Negative x squared plus 8x squared is going to be 7x squared. 2x cubed plus 0x cubed is 2x cubed. And then 4x to the 4th plus 10x to the 4th is 14x to the 4th. So there's our vertical way of doing it. The trap to get caught into here is when you're missing a term, like these. So it's really important to line up those degrees with each other. Again, though, we can look at doing this horizontally. And I'm going to rewrite this without parentheses. 4x squared plus 2x cubed minus x squared plus 7 plus 10x to the fourth plus 8x squared minus 3. Again, we can group these together using the associative property and put all our like terms together. This should be a 4. I'm going to go ahead and do that. 4x to the fourth plus 10x to the fourth plus 2x cubed. Yep, no other cubes. Minus x squared plus 8x squared. And now all we have left is constants. 7 minus 3. And now we just combine. 14x to the fourth. It's all by itself. 2x cubed. 7x squared. And plus 4. Now, we don't necessarily have to group them, but sometimes, like I said, it makes it easier to see. So, looked like I used my time up on adding polynomials, so I guess we're going to have a part 4 to this one about subtracting polynomials, and that probably won't take very long. So I will see you again in a very short amount of time.